So now that we've talked about the single class in the RxJava framework, it's time to turn our attention to the observable class. And this is really one of the workhorse classes that's used throughout many RxJava programs. Throughout the next several lessons, we're going to be talking about how observable can be used in the context of a number of different case study programs that we use as running examples. Case study EX1, which you can get at the link at the bottom of this slide, shows how to apply various RxJava operations synchronously to reduce and multiply big fraction objects. And we're going to see there's a whole bunch of methods we're going to take a look at here. So the first example we're going to look at here is called test fraction multiplication 1, and that's available in the link at the bottom of the slide. And it performs big fraction reduction and multiplication using a synchronous observable stream. And we're going to use this particular test fraction multiplication 1 method in order to demonstrate the just, map, and blocking subscribe methods that are part of the RxJava observable class. So let's begin with just. So what just does is it creates an observable that will emit the given element or elements, and then it goes ahead and completes. And let me move my head out of the way here so you can see just in this particular case takes a varargs parameter. So it can be basically an array of elements that are provided, one or more basically. So if we take a look over here, you can see that the main difference between just for observable and just for single, because there was a just for single before, is that the single just emits one element, whereas the observable just can emit many elements. So it's kind of one versus many. That's the main difference. And that, in essence, is the difference between a single and an observable. It's one versus many. So you can think of just as essentially a factory method that adapts non-reactive sources of input, like objects and their values and so on, into the world of reactive programming. And here's an example. We can say observable.just and then give a bunch of big fraction factory methods that'll make factory values for big fractions with different numerators and denominators. There's also a just method in Project Reactor's Flux class. Flux plays much the same role as observable does for Project Reactor. And again, you can use it in pretty much identical ways. And in fact, there's even the stream.of factory method that's part of the Java Streams framework that can also do something similar. You can give it a varargs list of values, and it'll go ahead and make a stream from that, a Java stream. So these are all kind of variations on the same theme. Let's now turn our attention to a transformational operation, the map method. And this will also be very familiar once you take a look at it, because it looks a lot like the map method that's part of Java Streams. What this does is it transforms the item or items emitted by this observable by applying a mapper function. And this is something very similar to the function that you would find in modern Java, Java 8 and beyond, except that RxJava predates Java 8. So they had to come up with their own set of functional interfaces. So this is actually a kind of a specialized version, but it behaves the same as the functional interface that we have in Java 8 and beyond. So it's a synchronous function. You apply it, it does its thing, and it returns a value. Now, normally all the mappers are applied for every element in the stream. But if for some reason one of the mapper invocations throws an exception and that exception is not caught, then that will terminate the stream processing. And that is no different from any other kind of exception handling. So there's nothing surprising or different here. In fact, it's basically the same semantics as you see with Java Streams Map. Also, as with Java Streams Map, the number of output items that are emitted by the observable after applying map must match the number of input items. So input and output have to match each other. Something else that will be very familiar to you is that map can actually transform the type of the element or elements it processes. So as a consequence, you can either have a different type. So for example, going from an integer to an employee record or a search results object or whatnot. And you could also, of course, change the value. You could go from having an integer with the value 42 to change it to 13 or whatever it happened to make the value change to. Doesn't always have to change the type, doesn't always have to change the value, but it's certainly possible to do that. The flux map method in Project Reactor works the same way. And of course, it should be no big surprise that the stream map method defined in Java Streams also works in essentially the same way. So the good news is once you understand how Streams map works, then understanding RxJava's map and understanding Project Reactor's map pretty much the same thing. The third method we're going to talk about at this point is the blocking subscribe method. And what this does is it's going to be used to subscribe a consumer to this observable. And of course, consumers are the things that are going to consume the data. RxJava sometimes calls these observers, but basically the same idea. This particular variant of blocking subscribe is going to have 3 parameters passed to it. The first parameter is a consumer that will consume the next element that is returned by the onNext call from the publisher or emanating from the publisher. The error consumer parameter will be used to handle any errors that may occur. And then the third and final parameter that's passed is a runnable, which is called complete consumer. So when the underlying publisher is done with all the data, it's done with all its emissions, and it says on complete, then that will be returned through this runnable parameter, this third parameter. The consumers, of course, are good old Java 8-like consumer interfaces, functional interfaces that can consume the data. They have a method on consumer that's called basically accept. This particular way of using blocking subscribe will lead to what's known as unbounded demand. It kind of breaks the chains that bind it, and it'll just return as much data as quickly as the publisher can emit it. So there's no notion of flow control, for example, in the context of this particular method. Signals that are emitted to this method, in other words, pushed from the publisher up to the blocking subscribe method, the subscriber, if you will, are represented by the following regular expression. So it's basically the onNext method can be called back 0 or more times. That's what onNext star means. And then either the onComplete or the error method can be called. Those are mutually exclusive. And if they're called, they're only called once, and they need not be called at all. So that's basically what the parentheses with the vertical bar means. It's either onComplete or on error. And the question mark at the end means it may or may not even happen, because of course there might not be any errors in the first place, and you might have a stream that never completes. We'll talk more about infinite streams later. The thing that's interesting about blocking subscribe is that calling this method will block the caller thread, the thread that's making the call, or the calling thread, depends how you want to look at it, until the upstream, until the publisher terminates normally or with an error. And this is very useful for certain scenarios. In fact, I use it in a lot of my simple test cases because it makes it easy to wait for the results to happen, to finish. In practice, you don't use blocking subscribe very much, and we'll talk later about why you don't use it, because it would totally perturb and interfere with the whole concept of asynchronous reactive programming, which is really the secret sauce of the RxJava framework and of reactive streams in general. Interestingly enough, there is no equivalent method in Project Reactor, which seems a little odd. In fact, it's kind of a headache. So there are times when you switch from RxJava to Project Reactor for various reasons. You're like, boy, I sure could use blocking subscribe around now. And there are other variants that get you sort of in the ballpark, but there's nothing that's equivalent directly, which is kind of weird. We're going to turn our attention to test fraction multiplication 2. And what this is going to do is it's going to perform big fraction reduction and multiplication using 2 synchronous observable streams that we merge together. So we haven't left the comfortable womb of synchrony yet. We're going to do that in the next section, but we are moving away from having a single stream. And this particular example can be found again in the EX1 folder, and it's going to demonstrate some of the methods we looked at before, like just and map and blocking subscribe, but it's also going to go a little further and take a look at from callable, repeat, and merge with. So these will be the other methods that we're going to take a look at. So let's start by taking a look at the from callable method. What from callable does is it returns an observable that when an observer subscribes to it, does certain things. And here's what it does. When the observer subscribes to it, the callable parameter that's been registered with from callable will be invoked at that point. And what it's going to do is it's going to give back an observable that will emit the value that was returned from that callable parameter. So this actually sounds more complicated than it really is. This is basically used to also, much like just, allow adaptation from non-reactive input sources into the reactive model. So here you can see a little snippet of code for from callable, where we're actually going to have it passed in a lambda expression, in this case, a a callable lambda. And that callable lambda is going to go ahead and make a big fraction when it's called. And what's cool about this and how it differentiates from just is that this callable, this lambda callable, is actually not going to be invoked until an observer subscribes to the observable. And so that makes that invocation lazy. And it means each time it's called, it could give you back a different result, which it will in this case. Conversely, the just method we looked at before is eager. It doesn't allow calls made later when the observable when the observer will subscribe to the observable. Instead, it produces the value when it's called originally. So it's eager, you get the value, that's all you're ever going to get, whereas the callable will reevaluate it later, so that makes it lazy. There's also a from callable method that's part of Project Reactor's mono class. There is no from callable method on the Flux class in Project Reactor, which is a little curious, but mono has a from callable. The next method we're going to talk about here is something called repeat. And what this does is it returns an observer that will repeat the sequence of items emitted by the given observable at most count number of times. So again, let me move my head out of the way here. You can see that repeat is given a long, which is the number of times to repeat the previous sequence of items. This method doesn't operate on a particular scheduler. It just runs in whatever context it's invoked in, and you can use it to repeat the same operation multiple times. Here's an example where it's being repeated twice. There's also a repeat method as part of Project Reactor's Flux class. So as you can see, there's a lot of commonality between these different frameworks. And then the third method we're going to talk about here before we dive in deeper into the example is the merge with method. And what this does is it's going to merge the sequence of items of the current observable, the kind of the calling observable, with the success value of the other observable source parameter. So again, let me get my head out of the way here. And you can see that the merge with method takes an other, and it's of course called on a given observable, and it'll go ahead and merge those things together. And what's returned is the new merged observable instance. And we'll talk about what merging means in a second. So what this does is it basically combines elements from the different observable sources, from the calling observable and then the other parameter, so that they appear as if they're a single observable source. And if you also take a close look at this, you can see that this may involve interleaving of the items. So you'll often get an item from the first observable stream, then one from the second one, then from the first one again, then from the second one, and so on. So it typically allows them to be interleaved. If you don't want interleaving, if you want to have all the first elements done, and then you want the next elements added to that, you should use concat with, not merge with. So merging can allow interleaving, whereas concat will put all the first ones first and all the second ones following that. So just a little subtle difference. Project Reactor has a merge with method and also has a concat with method that work exactly like the observable methods we looked at here. There's also a stream concat method in Java Streams that's similar to merge with. It's not identical, but it's along the same lines.